Okay. So, how are we doing tonight, everyone? Good. Good. I'm good, thank you. Welcome, everyone. My name is Holly Stoneberg, and I'm the Education Program Coordinator for Portage Park District. Oh, sorry. Oh, no. Okay. There we go. We're good. We're good. All right, go ahead. Right here, figuring out all the tech issues is Jen White. She's our Education and Outreach Manager, and we'd like to welcome you to Morgan Operations Center. Is anyone new to this building? All right, welcome. Has anyone been to Morgan Park? Just up north, right? So this is actually on the same property, but our operations crew and our natural areas crew work out of here. And then sometimes the education team steals the meeting room for things like this. So just some housekeeping if you need. Hello, come on in. How many chairs do you need? Okay, I got you. Bring them all in. Okay, good idea. Okay. So if you go down this hallway, not the first one because that's the kitchen, but the second hallway, that's where the restrooms are. I don't think he'll yell at you if you get up during the presentation, but he's in charge, so no promises. Okay. How many of you heard about this program from something that looks like this? Wonderful. Good. Anyone hear about it from our newsletters? Did anyone hear about it from the Sunday Oldies Jukebox? Yeah. I listened to it all Sunday just to hear it multiple times. But that's a good hookup. Have grandma. So, in case you don't know yet, this handsome gentleman right here, his name is Guy Zamputa, right? Oh,
I'm sorry. I told you.
Okay, Guy Z, right? We all know him as Guy Z, right? Okay, but I met him a couple months ago because this other handsome gentleman in the blue sweatshirt, whose also name is Guy, and like Jen said, we collectively call them our astronomy guys. Okay, so they're the ones that come out with the telescopes and cool things like this to teach us all about astronomy and what's going up just above, right? So Jen and I love and appreciate all things in the natural world, but there are some things, like everybody, that we need help with, right? So you call on the ones that know more, and they're the guys that help us learn about astronomy. So Guy, we met in the summer, right? I still had a summer intern when we first came this the spring. Yeah. So this when we first put this on the calendar, and I can't believe it's finally here, but he has been working tirelessly to get this program together, and I'm so excited that he's able to share this with you because it really is a cool program. But whatever questions you have, just sit back and enjoy. But we are going to turn the lights off. Is that cool with everybody? Because we want to feel like we're on a planetarium, yes? You can see okay. This. See, okay. This hall light will be on. Yeah. Okay. Yeah. Right. So
lights on just for a second. I'm doing that. Let's get a couple of questions.
Okay.
First of all, I'm a member of the comedy duo, two guys with a lot of telescopes. And the other guy is this gentleman here in the blue jacket, who probably about 3 or 4 years ago, it's been a while, hasn't it? He mentioned something to me called Stellarium. And it is an absolutely amazing program. And by the way, if you can't hear me in the back, let me know, please. It's a really fantastic program in what it does, but the other amazing thing about it is that it's free. So let me just ask a couple of questions here. How many of you consider yourselves to be beginners in astronomy? Okay. Anybody here who is an old hand at it and will be listening for all of my mistakes tonight? Yeah. Anybody here own telescopes beside him? Okay. What kind do you have?
Blank it out. Looks like that.
Okay, very good.
Shorter and bigger around.
And well, yeah, the bigger around part is the good part. And how many of you actually have a home computer or a laptop? Okay. Those of you that have the home computer will probably get the most bang for the buck out of Stellarium. It is completely free. It has a little bit of a learning curve, but once you play with it, your knowledge will build upon itself and you'll be able to do some pretty amazing things. one of the amazing things that I do at home with it is I connect it through Wi-Fi to my telescope. And I look at things in a stellarium, click them, and tell the telescope to go find them. And it does. And the amazing thing about that is that when you look into the sky, you can't see these things because the combination of the light pollution and the dimness of the object make it almost impossible to see them by naked eye, but the telescope will see them. So you put these two things together and you have this great aiming system that allows your telescope to find things that you would probably never find. Okay, tonight is going to be something like the old adage, give a man a fish and he eats for a day. How many of you know that one? Yeah, the other part of that adage is give a man a fish and he eats for a day. Teach him to fish and he soon gets tired of fish. You know, it's one of those deals. So we are going to kind of take a look at some of the things that Stellarium does. This is going to be a demonstration of Stellarium. And also I'm going to try to make this as much like a trip going to a planetarium where you've got the dome and you sit under there and the stuff moves around and is explained for you. And that is, I think, the most fun. So, as I said, this is not going to be a training course for Stellarium, but there are YouTube videos out there. And in Stellarium, there is a help file that gets installed when you put it on your computer. And there's an awful lot of information on the internet. So you can do that. You can look that information up if you have questions, even with a cell phone or a tablet. So let us get started. Now you can do the light. Thank you. Oh, and by the way, if you have questions, we'll try to hold those until the end unless I lose you and then speak up, because there's nothing worse than being left in the dust when you're trying to learn something. If you've ever taken calculus or anything like that, you know. Okay. Well, first of all, the question is, how do I get Stellarium? And that up. Everybody should have gotten a sheet that has some information on it. And there was a young lady up here who wanted to know about magnitude. We're going to talk a little bit about that, but there is a chart on the handout of comparative magnitudes of different stars. And you'll notice that they go all the way from negative numbers, the sun being -26, all the way down to, at least in the chart, 6.5, which is roughly as dim an object as you can see. Now, people often buy telescopes. You can ask Holly about this and and find out that it really is not adequate for looking at much of anything. And so I included a chart here, the comparison of light gathering power. And you can see that as the size of the lens or mirror in the telescope increases, the magnitude that the telescope will see under perfect conditions increases. You get down to the point where you're talking about there. And I also included some links to various dealers of telescopes and other goodies, and just some suggestions for brand names to look for. And then finally, there are some definitions here. But the thing to keep in mind is that the average telescope is good for about 50 power, or 50x, times the number of inches of objective that you've got. So if you happen to see an ad for a telescope that's got a 2-inch lens on the front or 50 millimeter, and they tell you that it's good for 600 power, they're blowing smoke on you, because it's just not true. It would never do that for you. But just, you know, keep that in mind. And I had originally included my email address, guyzyradio@gmail.com, on the opening screen, but you can always email me if you like. And if you need to get that email address, see me afterward. All right, so getting over to Stellarium now. This is what Stellarium looks like when you run it. And I've got it set up so that I'm looking at the northern sky. And does anybody notice anything that they recognize there? Okay, well, the one thing that you probably will notice down here, if I point it out, is the Big Dipper. This is not all the stars that Stellarium will show you. As a matter of fact, if I turned that on, the screen would just be about 4 times as many stars. It would be just a huge number. This is a manageable number. And in Stellarium, we have a couple of different ways of drawing grids on the screen. First of all, there is a grid that actually points to the zenith, which is the overhead. The zenith is the highest point in the sky. And that particular grid is helpful sometimes for locating objects. The other grid, which is also useful and interesting, is the grid that is based on that star. Anybody want to take a guess what that is? Yeah? Yeah.
I think it's like a special type of star.
Yeah, it is a special kind of a star. It is the North Star. It's called Polaris. And I'm going to turn the star names on right now and see that. Polaris is the North Star. It is not the brightest star in the sky, some people think. And during the course of the night, the stars that are out there all seem to rotate around Polaris. And so if you set a telescope up and said, let me see Polaris, and you put your scope on Polaris and you come back 2 hours later, Polaris will still be in your eyepiece. Everything else will have moved some or a lot. Anyhow, that is Polaris. And there are some other things in the sky that we can look at. For instance, the Milky Way appears in the sky, and that is this haziness that goes overhead. And right now it passes through a constellation called Cassiopeia. We'll talk about that a little bit later. There are some other stars here that we're going to go through and look at the constellations that they are associated with. Turn that off. Now, something else that we can do in Stellarium is we can take a look at the planets. And if we move over here, when you came in tonight, you might have noticed that there was a bright star in the eastern sky. That is actually the planet Jupiter. And it comes up right now, probably somewhere around 6 o'clock. We can zoom in on it. We will look at all the planets a bit later. In the southern sky, we've got the planet Saturn, which is everyone's favorite, actually. Let's just do a quick zoom in here and we'll come back to it later. And that's what it looks like in a telescope. It's an amazing view. And as I said, we'll come back to that with some facts and figures a little bit later. Now, another nice thing about Stellarium is that we can not only look at the stars that are in the sky that we can see, the northern hemisphere, but we can also look into the southern sky. And you'll notice we've got the planet Venus here. When you woke up this morning, anybody get up at about 4 o'clock and look out? I know Holly mentioned it. Venus is blazing away in the morning sky at about 4 or 4:30. Incredibly bright, and it is only half illuminated by the sun right now, but it's there and it's worth a look. So you can say that you've seen it. Oh, in the east, it's in the east. Now, right now the sun is below the horizon, but if we got close to the sun, we would find that the planet Mars. See, where is Mars? Mars is currently hiding behind the sun. It's on its way from being an evening star to being a morning star. And so it is there. Mercury is also in here. One of the nice things about stellarium is you say to yourself, I want to look at something, but where is it? Well, if I say I want to look at Mercury, provided I spell it correctly, there is the moon as it's visible tonight. And there is the planet Mercury. They are close together, relatively speaking. So you can take a look at the planets and you can zoom in on all of them. And there are some other things in the sky that you can take a look at, which most of which are too dim to see with the naked eye. And they are the nebulas and the other deep sky objects. You'll notice that a lot of them are distributed along the Milky Way. This is because they are a part of the Milky Way galaxy, and that's our galaxy. As you get away from the Milky Way, you see that there are fewer and fewer. And there are 4 different types of objects that Stellarium will show you, and they code them according to the type of object that they are. First of all, you have some with a small cross through the middle, which is something called a globular cluster. And I'm hoping that this one actually shows us. There it is. This is something called the globular cluster, and they are a group of stars. They're located around the periphery of the Milky Way, but they are a part of the Milky Way galaxy. And they are groups of stars that are held together by mutual gravity. One of the most famous of these, or the most well-known, is something called M13, which is the great globular cluster in Hercules. And again, I'm using the lookup because it just makes finding things much quicker. Otherwise, you sort of dig on them. This is roughly what M13 looks like in the telescope. It's pretty dazzling, especially at high power. The individual stars at high power actually begin to twinkle in M13. And there are a number of globular clusters all over the sky. Sometimes it's fun just to go out and start looking for them. Another item that I am looking for here is an open star cluster. It's a good one. Let's try this. Open star clusters are groups of stars that are not quite as dense as globular clusters. They, again, are held together by mutual gravity. And one of the best, the one that I find amazing every time I look at it, is something called the Wild Duck Cluster. And you'll notice as we move along here, the stars, generally speaking, all have Arabic names. And I guess this is because the Arabian shepherds didn't really have a whole lot to do. And they didn't play cards, obviously. And so they spent time looking at the sky and naming stars. And some of them have interesting names that are almost not pronounceable by Westerners, but that's the way it goes. Anyhow, this is the Wild Duck Cluster, and a lot of the objects, a lot of the nebulas and deep sky objects have names that are not Arabic. Some of the constellations have names that are not Arabic, and most of them have names that are after Greek gods or mythological characters. So let's see what else we have. There are some nebulas here, and a nebula is a cloud. The word actually means cloud in Latin. And one of the most notable, one that you can see with a naked eye, is in the scabbard of Orion. And we're going to go there now. But this is what that looks like. Now, the nice thing about this is that when you look up at Orion at night, you can actually see that fuzzy patch. And in a telescope or a pair of binoculars, it's even more impressive. And of course, in a telescope, it can blow your socks off, actually. It's just amazing. At any rate, let us move along then. And one of the things you're going to note as we look at different things is there are identification numbers up here. And some of those I have not looked up. I cannot tell you what they are. But I do know that the M's stand for Messier. There's a Frenchman who was actually a comet chaser. And he decided that he wanted to find out what items in the sky were not comets. So he didn't bother with them. And as a result, he put together the Messier catalog, and it contains a lot of nebulas and clusters and things of that nature. You'll see that they have M numbers. NGC numbers, some items are on multiple catalogs. NGC stands for New General Catalog. It's another way of categorizing objects in the sky. And generally speaking, each of these catalogs has a, how can I say, a flavor, which is just a little different than the last one. So you'll see those coming up, and I'll point out a couple of the others when we get to them. Let's see. Okay, so somebody wanted to know about magnitude. And this is something that is described on the handout sheet. But a few things to remember about the word magnitude. First of all, it's a way of categorizing stars and rating them according to their brightness. Now, the thing about magnitude is that as the numbers increase with magnitude, the object actually becomes dimmer and dimmer. And for that reason, if you look at an object which is bright, let's say it's the sun, it's not only a small number, it's a negative number. The magnitude of the sun is -27. There's a star Vega, which we'll take a look at a little later. Its magnitude is kind of the yardstick by which all the others are measured, and its magnitude is considered to be 0. At one time, Polaris, the North Star, was considered to be the yardstick, but they changed that because Polaris's brightness actually changes slightly over time. A couple of typical magnitudes for you. Sirius, the brightest star in the sky, -1.4. Jupiter, which is a planet, is -2. Venus can actually be -4. And the full moon, -12. So you can see that the magnitude numbers can go negative as well as being positive. By definition, as I said, Vega is 0. As far as how dim an object you can see with the naked eye, magnitude 6 is about it. Now, it turns out that in this particular area with light pollution, atmospherics, the smoke from the Canadian wildfires during the summer, all of that ruined a lot of skies during the night. There were nights when I would go out and say, tonight I'm going out with a telescope, it's going to be great. And I'd look out in the evening and the sky was murky and you couldn't see very much of anything. So magnitude 6 under ideal conditions for the human eye, generally speaking, in an urban area or we've got a lot of light pollution, maybe magnitude 4, 4.5 is about it. So with that information, let us continue. Okay, getting back to this. So you look in the night sky and let me turn off a few things here. Stars, and get rid of the background goodies. And we'll leave the planets for now. So how many of you have gone out at night and said, I am completely bewildered, I can't connect any dots? Anybody? Yeah, you know, that's a fairly common thing. Now, I was in Montana in 2015, and this is what the sky looked like in Montana. This is the north, the north. And about all you can see is the Big Dipper in that shot. And that is right here. Here's the bowl. And these two stars are pointing off to the North Star, which is off to the top of the screen. And if you look at the picture of the Big Dipper right now, roughly in about the same place, it's a nice thing, you know, at least nature is consistent, if not always understandable. Getting back to the pictures. There's another shot that I took looking in the opposite direction as Orion came up. And that's a lot of stars, but that's not the most that I saw because they took some timed exposures and the background is just plastered with stars. I mean, I can't tell anything in there. I've actually taken those photographs and tried to trace out different constellations to identify stars. Very, very difficult thing to do. Now, does anybody here see Orion? Can you see it? How many of you don't see it? Yeah. Right, it's pretty much in the lower center. And here is the belt in Orion, those three stars. Here is the scabbard, and I mentioned before M42, the nebula. That is the nebula. Now, the stars in this picture are elongated slightly because it was a timed exposure and there was no tracking involved. But that is what that nebula looks like to the naked eye, and you can't see it. It looks pretty much like that. So, stars galore. Getting back to Stellarium, we want to take a look at the number of constellations there are, and this is where we start to put together the stick figures that represent different things. These are there we go. These are the constellations that are in the sky. And some of them are kind of taxing because you wonder, how did they ever come up with that? Some constellations consist of 2 or 3 stars in a straight line. That takes some imagination. Anyhow, this can be pretty confusing and daunting, especially if you're trying to figure these out. After you've been at it for a while, you look at the stick figures, you can say, yes, I know what that is. But there are names that go with all of these. And sometimes you'll recognize the name, sometimes you won't. But it really gets to be kind of crazy when you put the mythological figures in here that go with the stick figures and the names. And this is where it becomes kind of intimidating because all of these constellations actually represent either mythological beings or Greek gods, sometimes just everyday things. Like there's a constellation called Telescopium. You don't have to be too clever to figure out what that's all about. And a lot of the constellations do have names that are Greek gods or mythological creatures. For instance, Pegasus, Cygnus the Swan is not a Greek god, obviously. Draco the Dragon. Here is, let me see, who do we have here? Ursa Major, the Great Bear, which includes the Big Dipper, and as I said, these are mythological characters in a lot of cases, and there's a lot of Greek lore and mythology that go along with these, and we'll talk about one of those in just a little bit. Which I'll have to give you the Reader's Digest version because I read about it and it went on for pages. All right. So let us start. So let's start with Ursa Major. And this is always a great place to start in the sky. What I'm trying to do is to get Ursa Major by itself. Come on. Well, as they say, the best laid plans of mice and men are often the same. Let's do it this way. This is Ursa Major, and there are two stars that can help you. That can help you. Dubhe and this star, whose name escapes me. Gillespie, what's the name of that star?
Johnny.
What is it? Oh, okay.
I don't remember. No, I have an excuse with me. I forgot about them.
I'll tell you what. We'll get some more stars and then we'll see it. Merak. Dubhe and Merak are the two side stars in the bowl. These are the stars that are often called pointer stars because they will point you in the direction of Polaris, which is Ursa Minor. Now, let's see if we can get the. There we go. That's what I wanted to do. Polaris and Ursa Minor. Let's get Ursa Major while we're at it. Okay. The Great Bear and the Little Bear. And let's see, we have talked about. All right, Dubhe and, or I'm sorry, yes, Dubhe and Merak are the pointer stars. They point off to the Little Dipper. And there is another star in the Big Dipper, which is notable, and you can see, it's called Mizar. It's a real double star. With a double star or triple, they tend to revolve around each other. And if you have a look, even a modest telescope, you can see these two stars. And Alcor revolves around Mizar, and actually they revolve around each other in a way. But they are a double star, and it takes about 750,000 years for one star to make a complete trip around the other. So if you were planning to come back and check tonight or something, it'll be pretty much the same. Now, as I understand it, in the time of the Romans, a test of a soldier's eyesight is whether he could actually make these stars out.
Yes.
If they asked you, if you knew that your job in the Roman legion rested on your ability to see those stars, how could they tell you? How could they tell if you were lying? You know, it's kind of a strange test. But at any rate, that is the double star system in the Big Dipper. And here we go now with picking out some other things. There is a set of stars here that make up a W, and it is the constellation Cassiopeia. Cassiopeia was a queen, and she got into trouble just a little bit because she made a few other gods unhappy. But at any rate, this constellation Cassiopeia is visible in our latitude, and you will see that over the course of a year, it makes a trip around Polaris, and we'll be back in the same spot next year. Now, over here, we've got another constellation, which is Perseus. And Perseus is a part of the myth, but I'm going to get the other constellation to go with it. Right here we have Andromeda. And that is kind of a cheery little tale that's really kind of grisly. A question?
No.
Oh, okay. I saw a hand on there. It's kind of a grisly story. You'll notice that on Andromeda's wrists, there are what look like chains. And she is actually shackled to a rock. What happened was she was the daughter of Cassiopeia. This is the Reader's Digest version, by the way. She was the daughter of Cassiopeia, and Cassiopeia boasted to the Nereids, who were 50 maidens of the ocean, that Andromeda was the most beautiful woman going and much better looking than they were. They took offense, and then Cassiopeia made somebody else angry, and the penalty. The punishment for this was that Andromeda was shackled to a rock where she would be eaten by a sea monster. The other guy in this little grouping is Perseus, and you'll notice he's holding what looks like a head. That is Medusa. He was given the task of cutting off Medusa's head, which he did. He brought it back, and somewhere along the way, there was someone who was upset about the fact that things were going the way they were, and so he held up Medusa's head and showed the head to this other god, and that god was turned to stone. That was the thing about Medusa. She had a head full of snakes. If you've ever watched any monster movies, especially the Hammer Productions, Medusa is always depicted with a head full of snakes. And at any rate, if you looked into Medusa's face, you would turn to stone, which was an unfortunate thing that happens, always happens in Hammer films. At any rate, we've got Perseus and Mirfak. And Mirfak, the definition in Arabic is elbow. And it looks more like it should be his navel, but it's not. It stands for elbow. And over here with Andromeda, we've got one item that is of note. And you would think that you should be able to see it with a naked eye, but it is the Andromeda Galaxy.
What?
Now, that's what it looks like in a photograph, and getting a good photograph is always tricky. It takes the right exposure, the right equipment, the right filters, the right nighttime conditions. What you get normally when you are looking at it in a pair of binoculars is something like that. I'm going to turn off the constellation background. But at any rate, you see something like that. A couple of weeks ago, I went out with a telescope and I attempted to photograph it. And in fact, there we go. That was my photograph of Andromeda. And it's not very, I mean, I wanted the other one. I wanted the one with the arms and the whole schmear. I didn't get it, but this is the first time I've tried photographing Andromeda. So there's more coming in the future on that. To Stellarium. So here we are. Let's get back to the Andromeda Galaxy. Turn that back on to make it beautiful. Now, an interesting thing about the Andromeda Galaxy is that the magnitude of it is about 3.5. So it is well within the range of the human eye to see. But in fact, when you look for it, even when you know exactly where it is, it's very difficult to see. You can see it instead of binoculars as just being a little tiny puffball in the sky, like the photograph that I showed you. But an amazing thing about the Andromeda Galaxy is it's actually 5 times the diameter of a full moon. It's very, very large, but the magnitude is such because the light is actually spread out over a large area. So in the telescope, even under high power, essentially you see what looks like a big cotton ball. But at least it's there and you can say, oh yes, I've seen Andromeda. Let me double check the time here. Okay. Moving along. Over here, we have Jupiter, the planet, and Jupiter is sitting right now in the constellation Aries of the Ram. Jupiter and all the planets actually move against the background because they are going around the sun. And so as we see them, that background changes during the year. And in about a year, it'll be in a different place entirely. And where it is going is to another constellation down here. Yeah. And that's where it'll be in 1 year. Taurus the bull. And the stars involved here. You'll notice that in a year, the moon will be where Jupiter is right now, but only for a short while. There we are. So Aries, the ram, and Aldebaran for Taurus, the bull. An interesting thing about Aldebaran is it is a variable star. There are stars out there whose brightness changes for one reason or another. Its magnitude changes between 2 and 4, so it varies considerably. And it's a red giant. No, I'm sorry, I said the magnitude was 2 to 4. That's not true. It is 0.75 to 0.95. It doesn't vary that much. But it is 44 times the diameter of the sun. And just to give you an idea of how large space is and how slow we move there, we have a spacecraft, Pioneer 10, and it is headed in the way of, in the direction of Aldebaran. It'll take 2 million more years to get there. And so, okay, now there's another star here that is easily visible. And I am looking for it is Capella. Where are you? Well, let's go back and search it out. Oh, there it is. And you'll notice that Capella is in a constellation called Auriga, who is the charioteer. I imagine this chariot is probably pretty slow because it looks like it's pulled by goats, in order to trust the picture. But Capella is a star an awful lot like the sun. And it's a sixth brightest star in the entire night sky. And it's actually a yellow star like the sun, but it's actually, in fact, a quadruple star system where you've got stars rotating around stars, rotating around stars. And it's very, very visible at night. As a matter of fact, we'll be able to see that tonight without too much trouble. Now, while we're here, let's take a look down here at Orion. Here we are. Here is the constellation Orion. And there's a star in Orion, Betelgeuse. And sometime on Google News or other news services online, they write sensationalist headlines and they'll say, Betelgeuse is about to explode. All right. And this got really, they got really worked up about 2 years ago because Betelgeuse its brightness had been diminishing by a noticeable amount, and you probably wouldn't notice it going out. But scientists who tracked this noticed that it was dimming, and they took that as a sign that Betelgeuse was about to go supernova. And if that happened, you would be able to see it in the daytime. It would cast a shadow at night. But as it turned out, the fine print said something like in the next 100,000 years or so. So, you know, they create crises online to get you to come and click and read their story, and then somebody collects 2 pennies. But anyhow, this is Orion the Hunter, Betelgeuse, and at the other end of it, Rigel. Some of these names actually appear in Star Trek, by the way. One of the things I believe that they were trying to get a shipment of drugs to combat an illness called Rigelian fever. That. But there are a lot of situations where science fiction has taken star names and planet names and weave them in. Over here we have Castor and Pollux, and when Gemini and Castor and Pollux come up at about, I would say probably about midnight, you'll be able to see both of them, and Orion will be above the horizon. Right now, as you can see, here's the horizon, the green line, and they are still beneath it. Here is an interesting star. Sirius is in the constellation Canis Major, which means big dog, and it is the brightest star in the sky, period. Its magnitude is minus 1.45. So that, you know, there are other things that are brighter, but as stars go, that's the king. Now, while we're at it, there's a star next door called Procyon, and it is associated with Canis Minor, the little dog. The whole point of the 2 dogs is that Orion was a hunter. And in fact, you'll see that he's got a club in his right hand, and it looks like he's about, or has already done the deed and beat up a tiger or something. But a good hunter always has a couple of dogs with him, and you know, that's the point of Canis Major and Canis Minor. Now, I want to make sure that I get to the planets, and so I'm going to move on to taking a look at the planets, because that's actually the most interesting part of this. And I'm going to turn off the stars and also turn off the deep sky stuff. And so here we go. We're going to start with the planets. And we'll see if we can find Mercury. There is Mercury. We're going to zoom in on it. And if you had a really incredible telescope, that's what it would look like. I have seen Mercury in my own telescope, and it's just sort of a little dot of light. Its diameter is about 3,000 miles. It is the smallest planet. If you discount Pluto as being a planet, you can argue about that anytime you like. It is cratered. Its day is 59 hours long, so it takes about 2 Earth days to rotate one time.
Okay.
And it takes about 88 days to go around the sun one time. It is the closest planet to the sun, but it is not the hottest planet. Anybody want to take a guess what planet that is? Anybody? Somebody say, did I hear Venus?
Say it loud and proud.
Yeah, Venus is the hottest
Yeah.
planet. Even though there's a side of Mercury that faces the sun, it is not the hottest. Now, see if we can find Venus. Yeah.
10 minutes, guy.
Pardon?
10 minutes.
Okay, Venus. Venus has some interesting facts associated with it. First of all, as I said earlier, when you get up in the morning, Venus is just incredibly bright in the eastern sky. It is called Earth's twin planet. It's about 7,500 miles in diameter. The Earth is about 8,000 miles in diameter. Venus doesn't have any moons, but the surface is thought to be volcanic. And between the volcanoes and the fact that the atmosphere is full of carbon dioxide, the surface temperature on Venus is something like, what do I have here? 900 degrees. You know, I mean, you can make a Thanksgiving turkey on Venus in about 12 minutes. An interesting thing about Venus is that it rotates backwards. That is, the sun rises in the west and sets in the east on Venus. Another strange thing about Venus is that the length of one day on Venus is 243 days, Earth days, but it only takes 225 days to go around the sun one time. So as a result, if you lived on Venus, a day is actually longer than 1 year. The atmosphere on Venus is pretty nasty. It is toxic, first of all. It is full of carbon dioxide, sulfuric acid rain. The atmospheric pressure on the surface of Venus is like going down 5,000 feet in the ocean. Extremely heavy. And it's about 2,400 pounds per square inch. Now, the atmospheric pressure right now that we are accustomed to is about 15 pounds per square inch. That gives you some idea. The longest time that a spacecraft has lasted on Venus was about 2 hours before it quit working. And there's some recent evidence that there's oxygen, a little bit of oxygen on the sunlit side of Venus. It was always thought there was some oxygen on the dark side, the unlit side. So let's move along to the moon here. I'm back. Can I go? Representing the Earth today is the moon. There it is. And that's what it looks like tonight. We have something called a new moon. If you get up tomorrow morning, you may actually detect no, it'll be tomorrow night or the next night. You'll see just a very fine sliver, which will get bigger as the month goes on. And it takes about 28 days for the moon to return to its current phase. It's about 2,160 miles in diameter. And if you viewed it from outer space, you could almost call the Earth a double planet, because the moon is roughly a fourth the diameter of the Earth. So together they are a reasonable size, reasonably similar size, unlike something like Jupiter or Saturn, where the moons are fairly tiny. The average distance of the moon from the Earth is 239,000 miles, but it varies from about 226,000 up to about 252,000 miles. And because of that, you remember last month we had the annular eclipse. The moon was actually at a further distance than normal. And as a result, the disk of the moon did not quite cover the sun. And so you end up with a ring, what they call the ring of fire eclipse. When it comes in close, the length of an eclipse will be longer. The solar eclipse will be longer because you've got more moon to cover up the sun. So just a little something. And it is, it has been fairly well mapped out. There we go. Most of the names of features on the moon are Latin. For instance, mare is ocean or sea, and crisium is crisis. And we can go to another view of the moon. where you'll see these names translated. There are a couple of craters here that are also labeled. You can find this information online very easily though. And you don't need to have a fantastically large telescope to look at the moon and enjoy it. So something to keep in mind. And people sometimes talk about the dark side of the moon, the side that we can't see. The word dark side is actually wrong in a way because it's simply the unseen side. One side of the moon faces the earth all the time and the other side faces away. And if you've ever wanted to know exactly what the other side looks like, let's get that. That's the moon's other side. And you'll notice it's pretty well hammered. A lot of craters and not much in the way of seas with the possible exception of this. And I don't have a map with the names on it. So that is the moon. And let us move on to Mars. Now, believe it or not, we cannot see Mars tonight in Stellarium because it's actually behind the sun, but we can cheat and we can move ahead. You should see Mars exiting one side or the other. If you get vertigo easily, don't look. Go back and see if we can see it again. Going to have a chance to see Mars tonight. This is kind of strange because earlier today and yesterday, as I was working on this presentation, Mars was there and it was very close to the sun. But because of the fact that Mars orbit is further out from the sun, it will disappear from time to time behind the sun or above or below it. But it makes a transition from being visible in the night to being a morning star, and it'll go then all the way across the sky, become an evening star again. So we happen to have caught it. I'm gonna try this again. If we manage to catch it anyway. No, it is not appearing. Well, there you go. Such is life. A couple of things about Mars. I mean, we all are, you know, the push right now is inhabiting Mars. That's going to be a bit of a job. Mars is red because the soil is full of iron oxide. The oxygen originally in the atmosphere is combined with iron, and the color is red, and it really is red. First time I saw Mars, there was no problem picking it out from the background stars. As a matter of fact, as you look at various kinds of stars in Stellarium, it will sometimes tell you that the stars are blue stars or red giants. And sometimes you look at the sky and you say, well, they're all just white. They're all just white light. And no, they're not. If you look at a star long enough and compare it to others, you will see color casts. And Mars was definitely red. And in the telescope, it looks red. And I do have a picture. Oh, here we go. We do have something to save us. Years ago, this was a photograph of Mars that I shot from the driveway. And it does have a polar cap. There's another polar cap down here. You can see just very slightly white. And it has surface markings. The planet has 2 moons. The day is about 24 hours long, but it takes almost 2 years to go around the sun one time. An interesting thing, and this is another one of those clickbait things on online. Phobos is nearing Mars at the rate, Phobos is one of the moons. Deimos and Phobos are the two Martian moons. And of the two, Phobos is closer. And it is getting closer and closer to Mars every year by about 6 feet. And that's 6 feet every 100 years, okay, which doesn't seem like a lot. But what that means is in 50 million years, it may break up or crash into Mars. And again, you will find headlines that say, oh, you know, Martian moon about to be destroyed. You know, don't pack a lunch and wait, because it's gonna be a while. So anyhow, that is the best we're gonna do on Mars right now.
Yeah, it's 7. Do you have an estimate to about when?
Yeah, I have a couple of more planets to go through, and I would say about 15 minutes we'll go outside.
Okay.
Okay, it'll work out. Okay, we do want to take a look at Jupiter and the other planets very quickly. Okay, here is Jupiter, the largest planet in the entire solar system. It has, let me see, the number is ridiculous. It's 87,000 miles in diameter, and a day on planet Jupiter is 10 hours. So it's spinning very, very quickly. And as a result, because it spins quickly, the poles are flattened. It actually bulges in the middle. So if you look at Jupiter in a telescope or in a photograph, you'll see that it is not really round. It's a bit flattened. It has a giant red spot. What I'm going to do here is turn on the rotation. I'm going to speed things up a bit. Wait a minute, too fast.
There's the red spot.
There we go. Yeah, there's the giant red spot. And to back up just a bit here. Come on.
It's the that, comet hit Jupiter. You can see the markings, like the 3 markings at the bottom. That's 3 of the collision points.
Anyhow, as it rotates in 10 hours, the red spot will sail by. We see that a couple of times a day. And it is a gaseous planet. It has a very faint ring system that doesn't appear here. Jupiter is twice as massive as all the other planets combined. It means if you took all the other planets and kind of, they won't necessarily all physically fit inside of Jupiter, but when you say massive, we're talking about the amount of matter that's there. And Jupiter actually has as much mass as all the other planets, actually more mass. It has 75 moons right now. And again, the 4 Galilean moons, they were seen by Galileo. That's why they carry that name. Ganymede, Europa, Io, and Callisto. I don't see Callisto here. It could be behind. Take a look at Saturn now. Okay. Okay, here is Saturn, and it is also moving and rotating. And another one of those great headlines was, and I just saw it today online, Saturn's rings are about to vanish.
What?
Yeah, it said Saturn's rings are about to vanish.
No, they aren't.
Well, yes, you're right. But let me show you how they are going to vanish. What happens with Saturn is it takes, let me see, what do I have here? Oh yeah, 29 years to go around the sun. And the rings are not always completely in line with the Earth. Right now, we see the top of the rings, okay? What is going to happen in 2 years, in the year 2025, is Saturn is going to look like that. And you'll notice down here the date, 11/19/2025. And as things continue, we'll then be seeing the other side of Saturn. And it'll continue doing that until we get back to roughly where we are now, which is in the year 2040. So, what's happening is Saturn, we are seeing the top and the bottom of the rings because we don't see it straight on. It's not straight on in its orbit. And it has, let me see, 83 moons. When I was growing up and studying in school, and when you had science class, they told you Jupiter had 12 moons and Saturn had 9. End of story. And as time went on, especially in the last 30, 40 years, every time we sent something to the planets in a spacecraft, we find out there are more moons. And they come and go. Now, the thing about Saturn's rings is interesting. It is now thought that Saturn's rings are there because a couple of moons broke up. And what you see are the bits and pieces of it. The rings are actually very thin. They're only, I don't know, a couple of miles thick, I believe. And yet, because they reflect so much light, we see them. But when Saturn does turn on its side and show the edge, the ring's edge on, let's get back. This is the current time. Now, several years ago, one of the first shots that I took was of Saturn. This was around 2018, and you can see how much further down the rings are and how much more we see them. When you look at Saturn in the sky, it does look yellow, by the way. You can pick up the color cast. Let's see here. Okay, 2 more planets, and I think we are finished. Now let's bail out of this. Nope. Yeah. Now, if we move out just a little more, there's a planet Uranus. But only if we spell it correctly. Wait. Here we go. There it is. And it has a system of rings. They're very faint. An interesting thing about this planet is that it is tipped over on its side. The North Pole of Uranus actually kind of points toward the sun. And there are various theories about how that would happen. One of them is that it was simply hit by something during the formation of the solar system. And this is what you get. It's a gaseous planet. And I have seen it with a telescope. And once again, it's not very spectacular.
Is that the one that's green?
Yeah, it's kind of a bluish green color. That is roughly what it looked like in the telescope. That is not a photograph of it though, because I went into Photoshop and made that. I cheated, but that's roughly what it looks like in the telescope. And Neptune looks about the same. I'm going to take a quick look at Neptune. And it is very similar, except that it is not tilted over. And it's got some moons of its own, 4 or 5. It and Pluto, the what used to be the furthest planet, Pluto, are in a strange dance in the solar system because sometimes Neptune is actually further from the sun than Pluto. And again, growing up, they always taught us Pluto is the furthest planet. And sometimes it's not. The orbit of these 2 planets, incidentally, they're about a 30-degree incline between them. So if you looked at a map of the solar system and the orbits, one of them is sticking up like a sore thumb. And last but not least, a quick look at Pluto. Yeah. Okay. Now, this is another one of the situations where you could say it's almost like a double planet. The largest moon that goes with Pluto is Charon, which is right here. Pluto does have 5 moons. And Pluto is considered to be a planet all the way up until I think the year 2006. And I'm looking for the date here. Yeah. August the 24th of 2006, it was demoted. So now I would say dwarf planet, but if you're a big fan of Snow White and the Seven Dwarfs, dwarfs don't live on Pluto. Not what's happening. At any rate, that's what I've got for you right now, and we are going to go outside and take a look at this stuff. If you
We're gonna look at stuff using Stellarium, correct?
pardon?
Look at stuff using Stellarium.
Yeah.
Okay. Are you ready for the lights?
Yeah.
It's bright.
So you might cover this, but in the app Stellarium, if you're using your device or your phone, you can turn it on night mode where it will turn it red, because if you go outside, it'll